You know, a set of triangles are similar if their angles are all equal. So if you consider these three triangles, you can see that they look smaller. One looks smaller than the other, and the orange triangle is bigger than the other two triangles. But all of them have equal angles. And so that's why these three triangles are similar. And you can see that their angles are equal when you place them on top of each other. So at first it may seem that, oh, these triangles are not similar, but once you place them on top of each other, you see that their angles are corresponding to one another, and thus showing that they're similar. Now another nice property that similar triangles have is that the lengths of the sides are proportional. So between the purple triangle and the orange triangle, the angles that are equal are marked. So angle A and P are equal, angle B and Q are equal, and angle C and R are equal. Because these angles equal, the sides that correspond to each of these angles are proportional. So we have this angle, side A and B, which is going to be proportional to P and Q. And then next we have side A and C, which is proportional to P and R. And the last we have B and C, which is proportional to Q and R. So between similar triangles, you can write out the ratios of the sides that correspond with one another, and then you'll see that they equal each other out. And we're going to actually prove this in the next part of this video. But before we do that, we want to study what are the criteria of similarity. So basically, when you're given 2 or 3 triangles, how can you figure out what factors will help you know whether the triangles are similar to one another or not? And there's 3 main ways of doing this. The first one is called angle, which means that if, let's say, you have these 2 triangles and you know that 2 of the angles are equal, then automatically you can say these 2 triangles are similar without trying to prove that the third angle is also equal. And the symbol is used to show similarity. So the purple triangle and the blue triangle are similar. The next method is side, 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 which means that if you have 2 triangles and all 3 sides are proportional to one another, proportional means their sides can be written as ratios that are equal to one another, then that means that the 2 triangles are similar. And the last method of similarity is if you have 2 triangles and they have an equal angle and then the corresponding sides of that angle are proportional, not equal, then those 2 triangles are also similar. And this is known as side angle side. So using these 3 criteria, if any of these 3 criteria hold, then you know that 2 triangles are similar. Now let's get back to proving that the corresponding sides of similar triangles are proportional. So the first thing I did was I placed our smaller triangle upon the bigger triangle so that the angle AQC falls directly on PQR, and they fall on each other perfectly because they're both similar triangles. So what we want to show in this proof is that the length of the purple triangle is proportional to the length of the orange triangle. And that can be written out as QA over QP is equal to QC over QR. And of course, you can also say that, well, what about AC over PR? But for the proof, as long as we show that 2 sets of corresponding sides are similar, that is proportional, then automatically we can assume that AC and PR are by similar argument are also proportional. So this is what we want to prove. And we already know that the triangles are similar, and the following two angles are equal. So that's what's given to us and what's known. So with that in mind, we know that AC must be parallel to PR since angle QAC is corresponding angle to QPR. And because of this, by the basic proportionality theorem, we can say that QA over QC is equal to AP over CR. And if you look closely, the length of AP, which is this line right here, can be represented as the length of QP minus the length of QA. In the same way, the length of CR can be represented as the length of QR minus the length of QC. So let's replace our fraction with those. So now that we expressed AP and CR as QP minus QA over QR minus QC, we can now cross multiply, which will give us QA times QR minus QC is equal to QC times QP minus QA. And then let's multiply these out. That'll give us QA times QR minus QA times QC is equal to QC times QP minus QC times QA. Now if you guys notice, these two parts of the equation are actually equal. QA times QC and QC times QA is the same as saying 2 times 3 and 3 times 2. So since they are equal, we can add QA times QC on both sides, and that will cancel these two out because they're being subtracted from one another. And our new equation, we're left with only QA times QR equal to QC times QP. And using cross multiplication, we can rearrange this as QA over QP is equal to QC over QR. And if you look back at our box of what we wanted to prove, this is exactly what we were trying to show. So we've proved that the sides of our orange triangle is proportional to our purple triangle. And we've already known from before that they were similar. So similar triangles have proportional sides. And you can use a similar argument to prove the sides are proportional using the other angles. Like instead of using angle AQC, as I have done, you could also use angle QPR or PRQ and use similar argument to show that the sides are proportional. So I hope that you found that helpful. Thank you for watching.